everybody. My name is Eman Khaled. I'm part of INOR's International Guidance and Mentoring Committee. Today, I will be introducing you to statistics. So let's start. First, what is statistics? Statistics is the discipline concerned with collecting, organizing, and analyzing data. Statistics is everywhere around us. When we say statistics, it doesn't need to be that complicated kind of data. It could be when you have several ways to go to a place and you are choosing the shortest one of them. So you are collecting data, you are analyzing it, and you are choosing the one that you want. Also, when ordering pizza, you can have statistics while you're collecting the order from a friend. You are collecting data, you are organizing it, and you are analyzing it to determine how much of each type do you want. So in statistics, we usually present data in charts, tables, and diagrams. Now, when we talk about research data, we usually want to collect information about a certain population or a target people. For example, people with a specific disease or people of a specific age or gender. However, in most cases, it's impossible to collect data on all of these people. So we usually collect information about a smaller group, what we call a sample. And now the results we get from the sample can be applicable on the population if the sample is representative. What we mean by representative is that the characteristics of people in the sample are similar to those of the population. So that if we have people with a certain disease of certain age group in the sample, the population that we apply this data on should have similar age group with similar diseases, so that we can apply the data on it. Now, talking about statistical data, when we collect data about any population, the data we get can be roughly divided into two types, either categorical or numeric data. Categorical data is the data that has categories, groups, and is therefore described by percentages or proportions. Things like male, female, elderly, adult, child, pass, fail. So you are dividing the people you are talking about, the sample, into different groups. And usually these data are represented by, as you said, percentage or proportion. So you say 50% male, 50% female, 30% elderly, 20% adult, for example. So that's how we represent categorical data. On the other hand, numeric data has numbers. It's rather than specific categories, things like weight, height, blood sugar level, number of children. To describe this numeric data, we usually calculate a little bit more mathematical values, things like mean, mode, median, minimum, maximum, range, quartile, standard deviation. And don't worry, we'll explain about most of these in a second. So, as I said, to understand basic statistical term, we have to see the definition of each of them. So let us start first with mean. Mean, or what's known generally as the average, is the sum of values divided by the number of values. So it's an average of data. You collect all the data you have and divide them by the number of units that you have. The mode is the most frequently occurring value in the sample. It's the value that most people have it in the data. The median is the middle value of the sample. When we organize the sample from smallest to largest, the value that lies in the middle is the median, so that half of the people have values over it and half have values below it. It's also called 50th percentile for that reason. The range is the difference between the highest and lowest values of the sample. So it's just subtraction of the highest value and the lowest value. The standard deviation is the spread and variability of the data from the mean. It's the average deviation from the mean. It tells you how dispersed the data is in relation to the mean. So let us see some examples. For example, if we have, let us say, this sample from 10 people about how many times they went to a cinema last month. And the numbers are as follows: 2, 4, 3, 1, 2, 9, 2, 1, 6, 2. Now, to calculate the mean, we add them, all of them, and divide them by the number of units. Here we have 10. So we add them and divide by 10, and we got the mean as 3.2. So on average, our sample went on to the cinema 3.2 times last month. Now for the median, we need to arrange data, as we said, in order and find the values that lies in the middle, like We organized it from smallest to largest, as you can see here. Yes. And then we find the value that lies in the middle. Here, since we have an even number of data, we have 10 units. So the values that lie in the middle are two values, so we take their average. We had 2 and 2. Without even taking their average will be 2. 2 plus 2 over 2. So the median we have is 2. So 50% of our sample went more than 2 times and 50% went less than 2 times or less. Now the mode is the most repeated value, and you can see that 4 people went 2 times to the cinema, so this is the mode. Now for the standard deviation, let us take two samples. Let us compare two data sets because it will be easier for us to understand it. So let us see these two samples. We have, for example, 48, 53, 56, 61, 62. This is set A. And set B is 34, 40, 56, 69, and 81. So if you want to calculate the mean for this sample, data sets, we can find that for both of them, it's 56. And here this symbol of mu is what we use to represent the mean, so don't worry. And the median, if we calculate it also here, they are arranged from smallest to largest. The value that lies in the middle is 56 here and also 56 here. So for these two data sets, the mean and the median are the same. However, if you want to look, we can see that the data sets are in fact not the same. They are quite different. So to find this difference between the data, despite having the same mean and the same median, we have to check the standard deviation to check that data are really similar or not. We calculate now the standard deviation and we can get it as 5.2 and 17.5. The calculation is a bit hard. We can leave it for when explaining more detailed statistics. But we can just understand the concept of standard deviation. And we can see here that the standard deviation is smaller for set A compared to set B. And that's quite understandable because in set A you can see that the values lie very close to the mean, 56. We said that standard deviation shows us how dispersed the data are from the mean. So we can see that 56 is the mean. The data are quite close to the mean. We can see 48 is just 8 below it and 62 is just 6 above it. So it's quite close compared to the second data set where we have 34 as the lowest and 81 as the largest value. So we have the data that is more spread. That's why the standard deviation is larger. The values are more variable. They spread over a larger range compared to the set A. Now let us see some research example. So for example, in this table we can look at an example of categorical data. If we look, for example, let us take this lower part here, architects. So here this is a categorical data because we can see that they divided the architects into categories, into groups, doing 1 library project, 2 library project, 3, 4 or more. And we can see that they wrote the number and as we said, they represented the data by percentages, 86, 9, 3%, 2%. So that's how we usually see categorical data. And we can easily understand it usually that, for example, in this example, 86% of the architects were doing 1 library project, while, for example, 2% were doing 4 or more library projects. Now, in this table, it may seem a bit complicated at the first, but let us take, for example, 1 row at a time. And let us see here, for example, life expectancy. For example, in Asia, here we can see it's 6.2. And between the brackets here, as they said, they put the standard deviation between the brackets. So the standard deviation is 11.8. When you compare it to Europe, it's 71.9. And the standard deviation is 5.51. So first we can say that, on average, people in Europe have higher life expectancy. But also we can understand from the standard deviation that the life expectancy is more variable in Asia. And that's understandable because we have some countries in Asia that have quite low life expectancy. And we have countries, for example, Japan has very high life expectancy. So the range, the variation of the data is large. Compared to Europe, which is less variable since most countries have similar life expectancies. Now we come to the end and we want to wrap everything up. So it's just to understand the basic statistics and the statistical data. It's just quite an overview of everything. Now, when we usually do it in research, we have a little bit more complicated calculation than only the mean, the mode, the median. And we also have a huge amount of data. We sometimes collect data from thousands and thousands of people. Therefore, there are data analysis programs that are commonly used to help us solve such a problem. These include things that are well known, like Microsoft Excel, which is widely available for population and can do quite a lot of the calculations. We have things like IBM SPSS, which is the statistical package for social sciences. It's also a statistical program, which is even more easy to use and more toward data analysis than only representing by table compared to Excel. And it's quite used in research. We also have an R programming, which is also a software used for data analysis. These can be used for more complicated or larger data samples that are quite hard to manipulate on your own. So thank you. Here, don't forget to follow us on Facebook, see our Instagram page and Twitter page. Thank you, everyone. Thank you for listening. Hope you benefited from it.